Next up, we are looking at nitriles, and in this video we're going to focus on the preparation of nitriles. We've already seen a couple of ways to make nitriles, and one is by doing SN2 substitution with cyanide. So if we have a primary alkyl halide, cyanide will act as a nucleophile, attack here, push out bromine as a leaving group, and we will make this substitution product. Remember, the carbon is the nucleophilic atom out of the cyanide group. If we have a secondary alkyl halide or alkyl tosylate, something with a leaving group, cyanide is mild enough or weak enough that it will still do SN2 substitution, not E2 elimination. So in this case, we will make this nitrile. But if we have a tertiary alkyl halide, then instead of doing substitution, this is going to do E2 elimination, giving us an alkene instead of a nitrile. So methyl primary or secondary alkyl halides or alkyl tosylates can undergo SN2 substitution with a nitrile or with cyanide in order to give a methyl or a primary or a secondary nitrile. Another way to make nitriles is by nucleophilic addition to an aldehyde or ketone. So cyanide can share its electrons, it acts as a nucleophile, shares its electrons with the carbonyl carbon, pushing these electrons up onto the oxygen. So after step 1, we have the O-, and we have a new bond with the nitrile. And then with aqueous acid workup, the O- can grab off a proton, and our product is this, a cyanohydrin. So nucleophilic substitution or nucleophilic addition, these are a couple ways that we can make nitriles. Another way to make nitriles is starting with amides. And so an amide can undergo a dehydration. So we're losing H2O to give a nitrile. And some of the common reagents that can be used for this include thionyl chloride, phosphorus oxychloride, and phosphorus pentoxide. So it's called phosphorus pentoxide even though it is P4O10. All of these are common dehydrating agents. So as another example, if we have benzamide, this can be treated with P4O10, for example, and that will give this nitrile. So with alkyl groups, with aryl groups, that's fine. Any of these dehydrating agents can be used to convert an amide to a nitrile. Although notice one limitation is that it has to be a primary amide, so a C double bond O NH2, not something with a C double bond O NR. It has to be a primary amide where the nitrogen is connected to two hydrogens, because we can lose H2O with a dehydrating agent, but we cannot lose an alkyl group if it's connected to the nitrogen. So preparation of nitriles can happen by nucleophilic substitution, SN2, that we've seen last semester, nucleophilic addition to primarily aldehydes that we've seen earlier this semester, or by dehydration of primary amides.